Good morning dear learners. I am Dr. Poddar, faculty of Bhila Institute of Technology, Durg. I welcomes you all. Today in this lecture session, we will learn about introduction to satellite communication. At first, we will see what it is mean by the word satellite. A satellite is a moon or planet or a machine that orbits a planet or a star. For example, Earth is a satellite because it orbits Sun. Likewise, the moon is a satellite because it orbits Earth. Usually, the word satellite refers to a machine that is launched into space and moves around Earth or another body in space. Satellite is a physical object that orbits or revolves around some celestial body. In general, satellite is an artificial satellite stationed in space for the purpose of telecommunication, military, surveillance, etc. And secondly, we will see that what it is mean by the word communication. Communication means exchange of information. Information can be either audio, video or data. Audio means audible, audible means listenable and talkable. A human being can able to listen or talk. In video, all picture and scene comes there, and else everything comes under the category of data. In mobile communication, since fourth generation, information means only data. The first practical concept of satellite communication was proposed by Royal Air Force officer Mr. Arthur C. Clarke, one who published a research paper in the year 1945 in the journal Wireless World, whose title is mentioned in your slide. Please read and note it down. The first artificial satellite was Soviet Sputnik 1, launched in 1957 and equipped with an onboard transmitter that worked on two frequencies, that is 20 and 40 megahertz. The first American satellite to relay communication was Project SCORE in 1958, which used a tape recorder to store and forward voice messages. Telestar was the first active direct relay communication satellite belonged to AT&T. Satellite communication started in 1965 by Intelsat. The first communication satellite was called Early Bird. There are three types of communication services that satellite provide: telecommunication, broadcasting and data communication. Telecommunication services include telephone calls and services provided to telephone companies, as well as wireless mobile and cellular network providers. In satellite communication, because of large distance, signal goes on weakening. Therefore, the system has to work under weak signal condition. For obtaining performance under these weak signal condition, a lot of effort has to be done for designing the antenna and amplifying system, and that is why in satellite communication the amplifier is not a conventional amplifier, means it is not made up of BJT, right. The amplifier is a low noise amplifier. Appropriate modeling and coding technique should be applied at some time for the earth station working with the satellite should be cost effective. Yes, since there are many uses of one single satellite, the regulatory requirement are specified for the purpose of coordination. Satellite system for communication, one is geosynchronous and another is non-synchronous or non-phase satellite. Geosynchronous satellite placed above equator and the speed of the satellite is same as that of spin velocity of earth. I will advise you all learner that stop or pause the video and draw the diagram that is shown in your screen, right, because to understand the satellite communication we have to study some orbital parameters, and for that this basic diagram you draw here, right. One earth station, that is on ship, it is shown, one satellite is shown. So, you draw this diagram, right. Here you will understand that angle of elevation and the slant range, which is the exact height between the earth station and satellite, and what is the altitude of satellite. So, all this thing we will try to understand one by one. So, you first draw that figure and then move ahead. For satellite communication, the Kepler's 3 laws are very important. So, we will try to understand these 3 laws first. Johannes Kepler was the German astronomer and scientist who developed these law for planetary motion, and that is very useful for our, or that becomes the basis for satellite communication. The Kepler's 3 laws, right, is a contribution of Brahe, Kepler, Newton and Einstein. All these scientists, their work together helps to make the Kepler's law for satellite. The first law of Kepler says that orbit of the satellite is curve of second order, such as circle, ellipse, parabola, etc., and one focus is center of earth. Second law says the area velocity product is constant, like in amplifier circuit we study the gain bandwidth product is constant. The same way area velocity product is constant, therefore, larger the radius of orbit, smaller will be the velocity. Third law, the square of time period of satellite is proportional to the cube or third power of semi major axis of the orbit. Now, this third law can be written mathematically as capital T square proportional to a cube. Small a is representing the semi major axis, and the proportionality constant is 4 pi square by mu, where mu is the product g m, where g is gravitational force, m is the mass of earth, and this mu is called the Kepler's constant. And putting the values of g m, we can find out the value of mu. So, that is the one greatest contribution of Kepler. With this Kepler constant, we are able to find out the value of a, that is semi major axis. For geosynchronous satellite, the orbital period T is 23 hours 56 minutes 4 seconds, approximately it is 24 hours, that we know. That 24 hours will convert into second, and we will put all this value into the expression of T and A, and from there we will able to find out the value of A. Once we find the value of A, right, then we will able to find out the height of satellite. For geosynchronous satellite, right, it comes out h is equal to approximately 36,000 kilometer. So, you all will do this calculation by your own. So, you have to be ready with the paper, pen and calculator and do this by your own. Similarly, we can find out the angular velocity. If we denote the angular velocity by omega, then it is represented as 2 pi by t. So, that we can find out. Similarly, we can find out the linear velocity of satellite, right, that is a into omega, and that comes out approximately 3 kilometers per second. Then to get a better insight of these orbital parameters, we will see two numericals. So, let us begin with the first. This again I will say, you just pause the video, write it down this problem, try to understand what the data is been given in the problem and what data it is asked to find out. I will just go through this problem. This problem says an inter-satellite relay allows message to grow from one satellite to another without passing through an intervening station. Calculate path length and minimum distance between radio path and the surface of the earth for a link between two geosynchronous satellites that are exactly 110 degree apart. Also determine the maximum possible separation between two geosynchronous satellites with a line of sight link between them. So, pause the video, note it down, then go through this figure, draw this figure, right, try to figure out all the orbital parameters that I have mentioned here. See, based on the data given, two satellites are 110 degree apart, right. So, satellite 1, satellite 2 are shown with the 110 degree separation, and there is a maximum possible separation between satellite 1 and satellite 2 with a line of sight. So, that is we are mentioning as m n. So, all this figure you draw and figure out all the parameters. So, you will able to understand. Then we know that semi major axis is r e plus h, h is the height of satellite, r is the radius of earth. Then from figure, right, d by 2 is equal to a into cos 35. So, from this we will able to find out the value of d, that is the radio path length. D is denoting the distance between two satellites S1 and S2 with making angle 110 degree with reference to center of earth. Then similarly, we can find out the minimum distance between the radio path and the surface of the earth. From figure, this is C A. So, we will calculate C A, and then last it is asked what is the maximum possible separation. From figure it is m n. So, m n we will calculate. So, you do all this calculation, so it will give you better understanding. Now, we will see the non-synchronous satellite, means the satellite whose height is not 36,000 kilometer, they are nearer. So, the velocity of the satellite is not same as the spin velocity of the earth. So, that is why it is called non-synchronous. It is not synchronized with the spin velocity of the earth. So, again for practice, for better understanding, you need to draw this figure, right, mention all the parameters. Phi v you can clearly see that is mentioned, right. So, that angle is very crucial. Here the t, it is less than the t, t is the spin duration of the earth, that is 24 hours. So, t is less than 24 hours. Another parameter here we have to understand, that is called apparent period. In case of non-synchronous satellite, with the case capital T, that is orbital period of satellite, it is less than the spin period of the satellite. Observer on the earth finds the satellite above his head after a period, that is AP, greater than T. Every this period is called the apparent period. This difference is because of the relative motion of earth and satellite. So, this non-synchronous satellite is low altitude satellite, right. It is less than 36,000 kilometer, and they are useful for the remote sensing purpose because of low altitude, and the period of satellite is smaller than 24 hours. Stationed on the earth can communicate with the satellite for a period smaller than t per revolution, corresponding to the visibility angle phi v. So, the expression for the visibility period comes out. If we denote visibility period by small t suffix v, so it will be T v equal to phi v divided by 2 pi into A p. Then again, to find out the phi v, we have to again draw this figure out, right. Here we have to draw the earth and the position of satellite and angle, elevation angle phi e, and another elevation angle from the surface of the earth phi I. So, here these two angle phi e and phi I are important. So, again I will advise you to stop the video and draw this figure, and then just again redraw the same figures as a triangle in that mention the point A, O and S, and here angle A is 90 plus phi I and angle S is 90 minus phi E plus phi I. So, using sine law we can resolve this to find out the angle phi E. So, expression for phi E comes out cos inverse R E cos phi divided by R E plus H whole in the bracket minus phi I. So, this expression useful to calculate phi E, and similarly we can have the expression for area coverage. From there we can find out the percentage area that is covered by the satellite for scanning. Then we can have similarly the expression for slant range, and we can have the expression the exact distance between the earth station and satellite. So, for practice you stop the video, note it down and try to by heart this expression. Then we will, for better understanding, we will move to another problem. This problem says a new weather research satellite is placed in a circular equatorial orbit, so that it moves in the same direction as the earth rotation. Satellite stores the data that obtained by scanning in the direction of earth and play back the data to the controlling station after each trip around the world. The orbit is to be designed so that the satellite can directly above the controlling station located on the equator once every 4 hours. The receiving station antenna cannot receive below 10 degree above the local horizon in any direction. Find orbital period, orbital height and the time interval for controlling station can communicate with the satellite for each pass. So, these 3 parameters you have to calculate. So, you have to pause the video, draw this diagram, right, local horizon, above local horizon 10 degree, the 2 positions of satellites are mentioned, angle phi is there, and we will find out the AP is given 4 hours. So, based on AP, the relation for AP, TE and T. So, from that we will able to find out T, right. So, first parameter is calculated, then with the help of Kepler's third law we will able to find out A. Once we find out A, we will able to find out the height of satellite. Then you can observe here it is coming less than 36,000 kilometer. So, orbital height is calculated. Then next we have to find out the visibility period. So, for that we need visibility angle, and visibility angle, for that we have to calculate elevation angle. So, that expression for elevation angle we will use phi I is given 10 degree. So, from that we will calculate phi E, and then phi E value we will calculate phi V, the visibility angle, that is twice phi E by, then from phi V we will calculate the visibility period T V. So, this problem once you will solve, you will able to understand the how orbital parameters are calculated for satellite communication and their importance. Then we will see the launching of satellite. For launching of a spacecraft into geosynchronous orbit, the launching vehicle with the booster is 3 booster is normally used. Again I will ask you to pause the video and draw this figure, right. Here 2 figures are there. In figure 1, right, half portion of earth is drawn and point 1, 2, 3, 4 are mentioned. So, accordingly you draw it, and in second figure the earth and parking orbit, transfer orbit and geosynchronous orbits are drawn. So, these figures you draw, figure out all the parameters that is shown there, and then you continue to listen the video. For launching of the spacecraft into geosynchronous orbit, launching vehicle with 3 booster is normally used. The firing of the first booster is done on the surface of the earth and completed on the point 1. From point 1 to point 2, vehicle moves because of inertia. Then at point 2, the second booster is ignited and the burning of the space booster is completed up to point 3. From point 3 to point 4, vehicle moves because of inertia, and at point 4 the last booster is fired for injecting the satellite into geosynchronous orbit. During its travel from Earth to geosynchronous orbit, the intermediate parking orbit and transfer orbit are shown in figure 2. The transfer orbit apogee point is on geosynchronous circular orbit, whereas perigee point is in the transfer orbit touching the perigee point P is touching the parking orbit. Once the satellite reaches the geosynchronous orbit, it moves with a somewhat larger velocity till it reaches the destination, and from there onwards the satellite linear velocity is approximately 3 kilometers per second, corresponding to the synchronization with the earth speed. Problem faced by satellite in the space. Once we launch the satellite, the space environment is very tough. So, satellite should be small in size and low in weight for launching purpose. That is the crucial requirement, that the weight of the satellite and size of the satellite should be optimum. But again the crucial part is that with this small size, the earning part, earning means for communication satellite, the communication part is the earning part. So, earning part should be capable of handling more number of telephone channels. So, at one end the requirement of size is size should be as less as possible. On the other hand, the number of channels should be as maximum as possible. So, these two contradictory technical requirement that has to be achieved tactically. So, that makes the design of satellite very complex. Moreover, the complete spacecraft in the space is subjected to very hostile environment, such as constant bombardment of radiation and subatomic particle. Hard vacuum environment is there. The spacecraft has to work for longer period under this condition without maintenance. Because of this, the problem of design becomes very complex. The design of satellite involves many engineering disciplines. Problem faced in communication. There is a delay of 300 millisecond between two links. So, this in satellite communication, this 300 millisecond delay is inherent delay, we cannot avoid it. So, all the effort we have to put to ensure that the delay is not more than 300 millisecond. Many a times when you have observed the television news channels, right, news. So, whenever the newsroom persons talks to the person which is somewhere at the remote point. So, there you clearly see that the person in the remote distance place, he responds slightly later than what it is has been asked to the or what has been communicated to that person. So, why this delay is there? Because in satellite communication there is a inherent delay of 300 millisecond. So, that cannot be avoided, but all the effort we have to put to maintain that delay only 300 milliseconds. It should not be more than 300 milliseconds. Because of size, the power generated in the satellite is restricted, because satellite we know it has to work in the remote place. There the source of power is only battery and another is sun energy, right. So, battery has to be right sufficient enough that whenever there is a eclipse period, so the battery should be able to withstand that eclipse period. And for solar panel, again the size restriction is there. So, we have to manage that solar panel in such a way that they should able to generate a sufficient power, so that battery can be recharged properly. Because of distance, system has to be arranged such that the delay never exceeds 300 milliseconds. This I explained you that the delay of 300 milliseconds is crucial, inherent in satellite communication, but the delay should not be more than 300 milliseconds. The space environment is very tough, hard vacuum is there, hydrogen gas 85%, helium 15% is there. So, it is very tough space environment. The chemical structure, the mechanical structure of the satellite has to withstand that. The thermal structure of the satellite has to face the solar radiation, that is nearly 1.4 kilowatt per square meter. In addition to that, other radiations are there, subatomic bombardment, right, X-ray, infrared rays, ultraviolet rays that troubles the chemical structure. These are the there are many energetic particles are there which are trapped in geomagnetic field. Because of magnetic field, eddy currents are generated. Because of magnetic field decrease in the spin velocity, the magnetic field is so hard, right, so high that it disturbs the spin velocity of the satellite, which is spin velocity is very crucial for the antenna orientation. So, again that becomes very crucial because of high magnetic field. Meteoroids and cosmic dusts are there. There is a chance that satellite may collide with this. So, satellite should be designed to withstand all above mentioned problem, and it should work satisfactorily without maintenance, because satellite is launched at a distance place. So, regular maintenance is not possible. So, it should capable of working without maintenance. So, we all remember that the main contribution for satellite communication is Kepler's law, right. Kepler's law is the fundamental law for satellite communication. The way we say that Snell's law become the basis of optical communication, similarly Kepler's law become the basis for satellite communication. There are 3 Kepler's law that we will remember, and based on this Kepler's law we are able to find out the height of satellite, how much far from a earth station. We will remember that there are 2 types of satellite, one is geosynchronous and one is non-synchronous. Geosynchronous means that is the distance between satellite is 36,000 kilometers, and non-synchronous that is less than 36,000 kilometers. Geosynchronous satellite is used for communication. So, here we have to understand satellite communication. So, satellite communication means we have to talk about the geosynchronous satellite. Geosynchronous or geostationary, both are the same word, never get confused. Geo synchronous means the speed of satellite is synchronized with the spin velocity of earth, and geostationary means, right, the satellite is set in a particular position in the orbital in orbit, and that is constantly scanning that particular earth area. So, geosynchronous means it is synchronized with the spin velocity, and geostationary means it is stationed to scan a particular geographical area. So, both are same for geosynchronous satellite, meaning of the both word is same. So, that is all for the session introduction to satellite communication. Hope you have understand the basics of satellite communication. Thank you.